$50 gift card. There's pencils. There's a little graduation rubber ducky, a stress ball, glow sticks, candy, little blue and yellow water bottle.
Blue and yellow water.
What? Anyone who's graduating this year, we're just random number generating. 100 days worth of prizes. Numbers 1 through 11 are all like physical prizes. All right. Just out of a list of all of the seniors. Yeah, so we're random number generating, and I'm just choosing the like line on Excel that goes with the names. All right, so applications of integrals. Are you ready?
No. No.
People say no.
Because when you explain it, it was like really fast.
All right, I'll explain it.
I was gonna say, I think like, that's not even.
Oh, I was right. You were going to be not.
I'm also not going to
Just
be
leave
here
now.
Friday. I'm coaching a hockey tournament down.
All right. Wait, did anyone get that? I just did this and all right. What was that? Oh, the pen, the fancy pen. Where am I? There he is. All right, so the front page of this, we're going to do kind of two big applications of integrals today. We'll pause in between. The first one, I've essentially put everything you might need to know about position, velocity, acceleration on the front of this page. So we're going to kind of talk through it. And then on the back of this page, I've put a free response together, if you will. I use air quotes because this is way more parts than would ever be on a free response. But I tried to think of all the different questions that you could possibly be asked about position, velocity, acceleration, and put them together in one context. We'll take a break after that. And then the kind of last page on here is a very popular current free response they've been doing over the past couple of years that I would call a rate in, rate out question. This was particularly my favorite type of free response because I think it makes a lot of sense to like think out the question and to logic through the way we're going to do that question. And they can give you very complicated scenarios, but they kind of make sense to think them out. So that's my favorite type of free response, which means you'll probably see one on your problem set. I'm pretty sure there's one that's pretty similar. You'll definitely see one on your upcoming test. Sachi was checking dates with me. She is exactly right. Next class is only going to be review. So for those of you that like haven't touched your problem set yet, it's going to be due at the end of next class, but you'll have the entirety of class to do it. That being said, I would check it out before like opening it for the first time next class. I'll also have some more review if you have touched your problem set, it's feeling good, and you want to practice some more. So, position, velocity, acceleration. We talked about, oh yeah, and then the test will be 2 classes from now. So what is that? Today's Wednesday, right? So Tuesday, yes, Tuesday is that the Ides of March? Is that March 15th? Is that what it's called? The Ides of March. Caesar? That's the thing. Julius Caesar got murdered that day. So then we're like, let's celebrate. I don't know.
No.
Stab your friends.
If you say so.
No, please don't. Please don't.
Yes, I prepared my statement, Your Honor.
It did get recorded. I was just joking.
Oh my goodness.
All right. So applications of integrals. We actually have talked about position, velocity, and acceleration before when we were talking about derivatives. because derivatives represent like a slope or a rate of change. So to get from position to velocity, we took a derivative. To get from velocity to acceleration, we took a derivative because those were rates of change. So that's kind of summarized right here and right here is those were our derivatives. Now, I told you back when we learned these the first time that this discussion was going to get way, way more interesting in the second half of the year. And that is now. Because now we have this thing called antiderivatives that can take me from acceleration back to velocity, and more importantly, from velocity back to things like position, distance, displacement. So we're kind of in a cooler position where we can go between these three layers with these two different calculus operations. So let's look at some other things in here. We now have a couple of different ways to talk about average velocity and average acceleration. These were the ways we talked about when we had derivatives, where we do like a change in position over change in time. That's the x of b minus x of a over b minus a. But now we have this thing that we talked about last time. Anyone remember what we called this thing with the 1 over b minus a integral from a to b? We talked about the area of like a green triangle-y curvy thing. The green. Yeah, this is average value. This is going to come up a couple of times today, but notice this v of t in here matches the velocity. So if I want the average value of a function that I'm given, I can also find average acceleration if I'm given an acceleration function. So this is kind of two different ways to find average velocity depending on the function that you're given. If I'm given position, it might look like a rate of change. If I'm given a velocity function, I might have to do some calculus to find it. Other things that we learned, moving left, moving right, that's kind of moving backwards, moving forwards, because usually we're talking about something called particle motion. So instead of like a random thing moving everywhere, we're kind of talking about a particle on the x-axis. So left, negative, right, positive. When we're at rest, our velocity is 0. If we're changing directions, we're talking about v of t changing signs. So going from forward to back or from backwards to forwards. And this was the last thing we talked about when we were talking about derivatives. We talked a little bit about speed. If you're taking physics, you might recognize speed as velocity without direction. Thank you. So just the magnitude of velocity. For us, our direction is just either positive or negative. So absolute value will remove that direction and just give us the magnitude. We did talk about speeding up and slowing down, where we would want v of t and a of t to have the same sign or different signs. We'll get practice with that today. Here's the new things. Last class, I think, or maybe a few classes ago, we talked a little bit about displacement versus distance. Anyone remember the difference between those two, displacement versus distance? Yeah, Matt.
Distance is just how far forward you travel.
Mhm.
Displacement is how far away you are.
Perfect. So a perfect explanation. So our total distance, we want to count all of that distance we've traveled as positive. A good way to make sure things are counted as positive is to absolute value them. So we want to count all distance as positive. If we're talking about distance from our starting point, if we walk forward and back, we can allow things to like cancel out. So that's why this one doesn't have that absolute value. We're just integrating our velocity. So we may have some, if you kind of connect back to area, may have some area above the x-axis, below the x-axis that's canceling out, and we're just getting our distance from our start. We're also going to talk about position at any time t. Now, this one looks a little bit confusing right now, and we'll talk about how we're getting it when we do an actual question. But this represents kind of our starting location. And this would represent kind of our displacement from any a given point, or kind of your net change of distance. And this is coming from the fundamental theorem of calculus, so kind of connecting back up to here. This is just saying our net change of distance is our end minus our start. Usually we're going to be solving for that end thing. So a lot of the time we think of our start plus how far we went. So here is our net change as well. And a lot of this will make more sense once we start kind of doing our questions. In general, I want you to think of our two operations in two very different ways. Our derivative will always give us a rate of change. That's a really big thing to remember. So if we ever want to go from like position to velocity, velocity is our rate of change of position. So I need to do a derivative. Integrals represent some sort of accumulation. Or you can think of that as net change is a phrase that gets used a lot. But essentially, if you want to go from a rate back to an amount of something, so like from velocity back to position, from a rate of change of bananas back to an amount of bananas, that's going to be integrals. All right, ready to do some questions? We're also going to play around with the calculator here. So a lot of today is going to be about setup and not necessarily like actually doing the calculations. A very wise woman once told me, if you are on the calculator section and you are doing something by hand, you are doing it wrong. That lady is the lovely Miss Kaczmarski, who is another calculus teacher here and was my calculus teacher. She was a good teacher, so we're going to listen to her. Does anyone know who Miss K is? Yeah? All right, cool. Good talk. All right. So we're going to do this kind of extended free response question, and we're going to use our calculator to do it. So some advice with calculators. One thing about the free responses is they're going to use one context at the top, specifically in this question, one equation for the entirety of the question. So one thing I like to do is to put that equation immediately in my y equals, because there's a way to reference it as we continue to go. Like I said, these calculator questions, you need to use the calculator. So this is not like SAT where it's just helpful. You are going to have to use the calculator here. So I'm going to put this equation into my y equals so that I can use it later on. Yes, ma'am. Okay, so let's go to mode and fix some things because math analysis has been doing some weird stuff. So can you guys go to mode? And essentially for us, we want all of the first things to be highlighted. So if you, like Sachi was saying, if you kind of logged in and you saw y1, x1, y1, x2, y2, you need to make sure this function is highlighted instead of parametric. Also, I noticed our V of t in our question has a sign in it. So you're going to want to make sure you're in radians and not degrees. So just hit mode and make sure you've got radian and function are the two most important. So then when you hit y equals, you should see this guy. All of your plots should be off. So none of those should be highlighted. And we're going to type in this function. So 1 plus 2 sine. I'm going to use x, because that's the graphing letter for our calculator. And mine's going to type in and look like that. If you are having issues, let me know. I can come help. I'm going to wax philosophical about the AP test while you guys are typing. The calculator section, so you have two calculator sections on your AP test. One is 15 multiple choice questions. I would say maybe half of those actually need a calculator. And then 2 free response of the 6 free response are calculator active. Those ones you'll definitely need a calculator for. All right, we good on our function? All right, if you press graph, it should look like this. Can you just check to make sure your graph looks like my graph? If your graph looks way too flat, you're probably in degrees. All right, he's a wild guy. All right. So this function that we put in, is this a position, an acceleration, a velocity? What kind of function is it? Velocity. All right, that's really important. Just like we talked about back in like unit 3 when we were looking at graphs, we want to make sure we know what graph we're looking at. So this is velocity here. We do have this 1 point of position. Now be careful, X is talking about position and T is like our normal X value, if you will. So this point right here, if I put it together, is like the point 0, 2. So this X is functioning kind of what we would think of as our Y value. I'll put some air quotes around that. So if you graphed this on like a time position graph, you'd be at 0, 2 as like your y-intercept. Kind of, yeah. So it's not like x comma t here. We're working with points that are like t comma x. I think the reason they use x a lot is, again, we're talking about particle motion. So we're talking about a particle on the x-axis. So at any given time, we want to know their x position. So time comma x. It is confusing, though. I agree. All right. So the first few questions. Yeah, pretty much. Yeah, kind of like you're looking down or like looking at a singular number line. All right. Other things. I think that's all the important information from the question. So let's start looking at part A. We are looking at time t equals 4. Is the particle speeding up or slowing down? We need 2 pieces of information to answer this question. Does anyone know either of them? All right, we do know at t equals 4. Do we need to know the velocity at 4? Yes. We need one other piece of information. What would you call the rate of change of velocity? Acceleration. So we also need to know the acceleration at 4, which is, acceleration is our derivative of velocity at 4. So we're going to make our calculator find these 2 pieces of information. Now, I am already given velocity, so I just need to plug in 4 to the thing I already have graphed, and then I need to take a derivative. So pick up your calculators, and let's find it. So first one, I have v of t graphed, so I'm going to use the graph. Does anyone know what button we could use to easily plug in 4 on the graph? Trace. We're going to press trace 4, enter. This y value at the bottom here, where is he? This guy is the number we want. So 2 point, how many decimal places? 3. 2.978, or you could go 2.979, depending on whether you like to truncate or round. You can also do more decimal places if you want. I like to truncate, which means just cut the decimal off, because no more thinking. So 2.978. Can anyone tell me anything about this particle based on that number? All right, it's going forward. So usually on the x-axis, that would mean what's forward? To the right. Exactly. So we're moving right. We do. So now we need to find the acceleration to decide whether we are kind of speeding up to the right or we're slowing down to the right. I find this easiest to do on the home screen. So I'm going to press second quit, which is second mode, or you can try to like rage clear until you get back to this home screen. Yeah. All right. So pretty much everything you need on the calculator is under the name of this class. This is a math class. So does everyone see the button math right under the green one, alpha? All right, what thing are we trying to do? We're trying to find acceleration, which is velocity's rate of change. All right, we want the one that says n deriv, because we want to take a derivative. What does the n mean? I actually don't know.
It's probably not.
Yeah, but I don't like when I don't know the answers to good questions. I will try to find out. All right. So I want to show you some cool things you can do if you would like to. Does anyone think they know what I'm going to put here? All right, our variable needs to go here. So it could be t if I were doing it on my paper. Since I typed this function in with x's in it, it just needs to match whatever letters in my x. Now, is anyone not super psyched to type that function in again? Like they're just like, I already typed it in y1, I don't want to type it again. All right, if you're feeling lazy like me, there's actually a way to reference the function that we put in y1. I'm going to do this a couple of times, so maybe watch once, I'll type it all over again. If you press the green button, alpha, and then our favorite graphing button, trace, you actually get a menu of all the functions you put in y1 through y0. Now that's really helpful because actually flip your notes to the last page really quick. Look at those functions that they're putting in there. Those are not fun to type. So if you can really focus 1 or 2 times on typing those functions, you can then reference the ones you want. So I would put the y1 here because that's where I put my function. And I want this value at t equals 4, which is now x equals 4 for me. I'll press enter and I'll get this number. I'm going to do it again just in case you missed it the first time. So I'm going to go to math. We're looking for a derivative because we're finding rate of change. Our variable in our calculator is x, even though it's t on our paper. I could type this whole function in a set of parentheses. That'd be totally fine. But I already typed it in y1. So I'm going to press alpha trace 1 and at t equals 4. Again, I'm going to write this number down to 3 decimal places on my paper. I've got negative 1.164. All right, now before we go to actually answer this question, I do want to reflect on the work I'm showing on my paper. What you do want to avoid is just writing down a number. You kind of want to label what you're doing. So mostly that's why I wrote what I wrote here, is to kind of show whoever's reading my question, whoever's grading my question, what the heck I'm doing in my calculator. So I'm labeling this, hey, I'm taking a derivative to find a of 4. What you want to avoid is just like writing down these two numbers. So that's really confusing. What are those numbers? Why do I care about them? So make sure you're labeling your work as you go. It won't feel like you're writing a lot down, but we do want to label what we're doing. All right, have I answered the question? All right, you think it's slowing down? Who thinks it's slowing down? All right, why? All right, is it just because acceleration is negative? All right, what if I had gotten negative 2.978 and then negative 1.164? Would I still be slowing down?
Oh.
No.
Less than.
So the reason we are slowing down, and this is the only reason you are allowed to say on the AP test, is because the V is positive and the A is negative. So what you can say is V of 4 and A of 4 have different signs.
Did you say V of 4 is greater than A of 4?
So that also wouldn't be enough, because if this had been a very small negative number, essentially what we want is this is making it so the magnitude of this number is getting smaller. So as this is negative, it's pulling it from 2.9 to something that's closer to 0. If, say, this had been negative, this had been positive, that's also pulling it towards a number that would be closer to 0. If these had both been negative, this is going from like negative 2.9 to like negative 3, negative 4, that's getting faster. So you want to think same signs, different signs. Sadie, you had your hand up? Okay. Same sign, speeding up, different sign, slowing down. Doesn't matter what the actual number is, but I do want to say those numbers for grading purposes.
So even if they're both negative, that's still an increase?
Essentially what that would look like on the graph meant is you would be, so let's say I have a graph of velocity. If I had a negative velocity and then negative acceleration, you're taking a negative velocity and you're moving it away from 0 because I'm getting more negative. So it'll be going faster in general. So here we have a positive velocity, but we're negative acceleration. So we're getting closer to that 0. We're slowing down. All right, let's look at the next question. So we want to find all times in this interval when the particle changes direction. All right, we can look at the graph. What would we be looking for? All right, so we would want V of t to change signs. That's going to be helpful for our justification. Any tips on looking at this on the calculator? I saw that the graph looked kind of crazy. Ooh, that's a good idea, Jarek. I can't speak today. I've been saying just the weirdest things all day. Derek, that's a great idea. Let's go ahead and change the window. I think I tried to say Derek and change at the same time and ended up with Jarek. It's fine. My dad used to say my sister's name and then mine. Her name is Megan and mine is obviously Mel. And if you say them in succession, it sounds like male. So So that was my name. All right, so I'm going to go to window. So again, you don't have to do this, but looking at this graph, it's a little crazy. I want to change the window, so I'm just looking at the part that they're asking me to. I'm going to change my y min and y max to, or excuse me, the x min and x max to what they told me, the 0 to 3. It only happens once. I also like to change, especially with trig functions, those are generally pretty short. As far as like vertical stretch goes, I like to change my y min and y max to be a little bit smaller. I generally start with -3 and 3, and if I don't like it, I can round to go back and fix it. So, is Herbie right? It only happens once? All right. Could you tell me in like math terms, what are we looking for on this graph? All right, change in sign. Think graph words. Sorry, I'm asking a really vague question, wanting a specific answer. Cool. What's a crossing the x-axis? What's that called? A 0, a root, an intercept. I actually want to focus on the word 0 because that's the one we're going to need to find. So I could trace and try to find that, but it's not going to give me an exact answer. So what I want to do is find an exact answer going to the second calc menu, which is second and then trace. Do you see the option I want to pick? 0. I want to pick number 2 for 0. Second trace, it gives us an option of things I can do to this graph. The 2 you're going to like the most are probably 0 if we want to find an x-intercept, and number 5, intersect, if we ever want to find where 2 graphs meet each other. We'll do that later today. Notice you can find a derivative and an integral on the graph if you want to. The integral one is cute. It shades the graph for you. We'll do that later. All right, so I'm going to choose 0. This one gives me a couple of weird questions, and it asks them down at the bottom here. What do you think it means by left bound? Yeah, so a number that I know that's definitely less than the number I want. This cursor is kind of where it's currently at. That is to the left of what I want, so I'm just going to press enter. To get to the right bound, so a number that's definitely to the right, you can either scroll if you would like, or you can type in a number. I know that the far right of my screen is 3, so I'm just going to press 3 and enter. And then it asked me to guess. Since Herbie noticed that there is only one intersection here, it's going to go to the one intersection that's there. Really, you just want to make sure that you're closer to the intersection you want than to any other intersection. So, yeah, and you could certainly guess if you wanted to. I was just going to be lazy and press enter, but that works. So 2.707 is the number that we want. That is a time t, so I'm going to say, not in highlighter, t equals 2.707, and then we kind of already wrote the justification over there, but I'm just going to rewrite it because v of t changes sign. You could also be more specific. I heard Derek saying more specific language changes from positive to negative. I generally go with the vaguest possible language in case I make a mistake and like write it the wrong way. All right, so these still have been reviewed. Last one. All right, on the interval 0 to 3, sweet, still looking at that window. I want to know, when is my particle moving to the left? Do I? How do I know when my particle is moving to the left? When what's in the negatives? When the velocity. Good. I like the reference of the names. So v of t is less than 0. So Derek's actually right. The y value of what we're looking at is less than 0. That's what we want. But we want to be careful about saying stuff like y value because we're going to be talking about multiple functions here. So here we want velocity to be less than 0, which on this graph is our y value being less than 0. Could anyone describe an interval where that's happening? Yeah, so 2.707, and I like Derek ending at 3 since that's the only place we're looking at, and it's asking us between 0 and 3. So I'm going to say, should we do interval notation, or let's just do this. Less than t. I'm just going to reflect their notation because, so looking at this graph, you said we wanted velocity to be negative. Since this is a graph of velocity, we're looking at where the y value is negative, so where my guy is blinking over to the end, so below the x-axis. You probably could. I would reflect their interval there. You wouldn't be wrong, and I doubt they would take off points for that, for something so specific. Yes. Can you just ask me your question again so I make sure I answer it? Yes. All right, so we have, this is a graph of velocity. We found the place where velocity is 0, essentially, because we found where it changes sign. So that number that we found in the previous question, the 2.707, that's where my cursor is right now. And I want on this graph, since this is velocity, for this graph to be less than 0, I want it under the x-axis. So I'm using this little part right here under the x-axis. So again, kind of like when we looked at those graphs of f prime and talked about f, we want to translate our statement into what we're looking at and then keep going. All right, so that's kind of all review, to be quite honest. Let's get to the new stuff. All right, the good old debate of distance versus displacement. Letter D says, find the change in position of the particle between t equals 0 and t equals 4. Herbie says displacement. Do you guys agree with him? He's right. All right. So this is displacement. All right, without flipping to the front, if you can. Absolute value or no absolute value? No absolute value. We want our velocities, our distances to be able to cancel out because we just want to know how far we are from the starting point. Now, if I'm going from a velocity function, that's what I'm given, back to a position function, what calculus thing do you think I should do? An integral. That would be, ready? This is the first time I've dropped this joke. That would be integrate. It's my favorite joke. Thank you. Been working 10 years of calculus.
That's the first time you said that?
This year to you guys. BC, I've said it a lot. All right. Do they think it's funny? I mean, Nina thinks all my jokes are funny, but she's a rare breed. No, we do something called U substitution. That one gets the most groans / laughs. You'll see. We'll get there soon. It's 7.1. We'll get there very soon. What do you think the bounds of my integral should be? 0 and 4. Don't think too hard. All right. So as far as my work, there's some pretty strong air quotes on that. As far as my work, that's going to be my work for this question. Yeah. Well, we have to find the number. All right. Should we do you guys want to do the integral on the home screen or on this screen? Let's do it. Let's do both. All right. So let's rage clear our way back to the home screen or second quit. And where do we normally go to get our stuff on this screen? Math. And which one do you think I want? Math 9. Love pretty print. I'm just going to fill in exactly what I want. So 0 to 4. And you know what? I don't feel like typing that function again. Anyone remember how to get it? Close. Alpha trace. All right. And we put it in Y1. So notice I can really get away with a lot of stuff if I just type my function once. Just make sure if you're going to type that function once, you type it right. All right. Your calculator may take a hot second to do that math. It's okay. It's thinking a lot. You guys get 5.815? All right. If you wanted to do that on the graph screen, I'm going to zoom 6 out so I can see a little bit farther because I need my upper bound to go to 4, just so you can see how cute this is. I can go to second calc and choose number 7. I believe it asks you for the lower limit, which is the lower bound. So 0, the upper limit, which is the upper bound, which is 4. And look how cute. It shades it for you. Adorable. I like it on the home screen better because it looks more like what we've been doing. All right. Which one? Home screen or here? Home screen. Rage clear. Math. Number 9. Put in my bounds 0 to 4. Oops. I can either type my function in the inside, or we can press alpha, the green button, and trace, and I put it in Y1. And then you want your X to match the X's that you typed in on your Y1 screen. Cool. All right, let's really talk out the next question. This one's kind of the most interesting to me, I think. So we want to actually find the position of our particle at t equals 4. So I would say the thing we did in the previous step in letter B of this is very important to this question, but it's not the whole thing. Why is 5.815 not the position of the particle at t equals 4? That's the change. So what am I missing? What piece of information if you had to describe it in words? That's another vague question. So let's say I'm running around on the WNOD trail, and I'm like, I ran 5.815 miles. Come pick me up. How? What else do you need to know? Where the heck did you start? Yeah.
So you define
yeah, I need to know where the heck I started. Does anyone know where the heck I started in this question? All right. At time 0, what was my position? Remember this point back up at the top? That 2. If you ever think you need more information in a free response, look up. It's usually in this paragraph because they're like, you're not going to read that paragraph. I know you're not going to. You're going to look for this equation, then you're going to stop reading. So what we need to do is we need to take where we started, plus we need to know how far we went, which we can call our net change. To put that in kind of mathematical lingo, we need to take our position at 0 plus our integral of our velocity, which is our net change, our displacement here. So we're going to take 2 plus the number we got. And if I can add 5 and 2 correctly, I think that's 7.815. Yeah.
Are we going to calculate label these 4?
So you would want to be writing kind of these 2 steps right here, probably. Yeah. Otherwise, on the AP test, if they're just numbers, they're called like bald answers, and they get exactly 0 points. Sadie, repeat that question because I got distracted.
Why do we add them together?
Okay, so a couple of reasons. If you think about, so if you go back to my like trail analogy there, say I started at mile marker number 2, and I know I eventually ran 5.185 miles forward, I would end up at mile marker 7.815. So that's 2 forward and then another 5 forward. So I'd add them. If you want a calculus reason, this is coming from the fundamental theorem of calculus. So kind of rewriting here, this guy here, if I took my antiderivative of velocity, I would get position, which this would then give me plug in the top bound minus plug in the bottom bound. Notice if I wanted to move this to the other side, I would have to add it to the other side. So some people do like to set up kind of this step of the fundamental theorem of calculus. If that helps you a little bit more, kind of feels similar to some of those graph questions we've been doing, definitely can start it there. This is the way my calculus teacher taught me. So, all right, let's finish these last 2, and then we'll take a pretty strong break. All right, find the total distance our particle traveled from 0 to 3. Tell me what's different. Total distance. We want to count all of our distances positive. So if I went on this run, if I ran back home to grab a different pair of sneakers and ran back out, I want to count all of that distance towards my run. So I'm going to absolute value my velocity function. Thoughts on bounds? 0 to 3. We don't need to get that creative. All right, so let's go back to our calculator. Again, like Matt said, we do want to label our stuff, so I will want to say this piece before I kind of go to my calculator. All right, I'm going to clear out my screen. All right, integral, math, 9. Bounds, 0 to 3. Who remembers where absolute value is? Math, num. We have to go over. This one's kind of hidden. So you go over to num, and yeah, it's abs, number 1. All right. I could type my whole function again. Remind me one more time. How do I get to the reference place? Alpha, trace, and I put it in Y1. And we're going to do dx. This one will probably take your calculator like a good 20 seconds to think about sometimes. So be patient. You're asking your calculator to do kind of a lot of math there. So just take a mental break. That's okay. Yeah, there you go. You could be a nerd like me. You're actually allowed to 2 calculators on the AP test. So we have like 2 different types. So I would like let my calculator do work and move on to the next question. It's a little embarrassing, but you know, here we are. Yeah, absolutely. So I did math 9 for my integral. Typed in my bounds first. Then to get that absolute value bar, I went to math, over to num, and used the first one. Kind of the most hidden thing you're going to need. Alpha trace to get my function, or I could retype my function again, and then dx. Yep, so you're kind of changing your variable from what's on your paper, but it needs to match what's here. And if I'm using the calculator, I really need to use x's as my variable of integration. That's what it understands. What? I would say if you had t in there, it might be weird for the y1 here. The t on the x1 is if you use actually what Satya's calculator was in, the parametric mode. It needs t as its variable because it has an equation for x and an equation for y. So, all right, 5.301. Oops. All right. The last question we're going to be looking at is this one right here. It has us evaluate something straight away. So we can just kind of plug this into our calculator. But then it has what's called an interpret the meaning question, or explain using the context of the question. This happens to be one of kind of the hardest pieces of the AP test to earn like 1 point. So we'll talk a little bit about an acronym that you'll probably think is funny, but let's see if we can all plug in and get the same thing for this value. I'm going to label it. So I'm going to do 1/3, 0 to 3, b of t dt. While you're typing in, I want you to think about why the heck is that 1/3 there and what is it helping us to find. I'm going to do 1/3 math 9, 0 to 3. I'm going to alpha trace again. So notice if you're going to use that alpha trace, please make sure you type in your function the first time correctly. Let's see if anyone else gets this number. 1 point something? Yes, maybe. Anyone else confirm? Oh, okay, cool. Everyone's just staring at me. All right, I'm going to go 1.657. You could certainly go 1.658 if you are team rounding. I like being lazy. All right, does anyone know what this 1/3 is doing? Right, dividing it by 3y. What would that do? Okay, so yeah, this is like our change in distance right here. So if I had to write, this would be like x of 3 minus x of 0. I can write 3 as like 3 minus 0, right? So that's where my 1/3 is. What do you guys think that is? A change in distance over a change in time? Maybe. Let's peek up at the top. Anyone see something that looks kind of like that? Average velocity. So if we have that 1/3 out in front, what it's doing is it's adding up all of our distance, so our change in distance over our change in time. So these are kind of equivalent ways to write this. But if you see this fraction out front, and that fraction represents the distance between your bounds, this is our average velocity. So I'm going to say this is our average, and it would be whatever functions inside here. So that's why I'm saying average velocity. If I had been integrating acceleration, it would be average acceleration of my particle. Now, when we interpret the meaning, we actually want to say three things, one of which isn't going to really make sense here because I don't have units. But here's a cute little acronym that usually everyone thinks is funny. N, U, T, nut. You need a number.
I don't get it.
You need units, and you need time with units. So I know this one doesn't really make sense because we don't have units in this question. What units could this have if it's an average velocity? Miles per hour, meters per second, something like that, velocity units. So I would say this number is the average velocity of the particle, and I could put my units here. But the time is the most specific part. People don't put this time down. So I'm going to say from when to when. 0 to 3. So 0 times 0 seconds, whatever time unit is, 2 times 3 seconds, hours, whatever it is. We'll practice a lot more with that because of the like singular points on the AP test is probably the hardest one to get. This part with the kind of the pink part down here is me interpreting the meaning. You could also see the words explain in the context of the question, something like that.
So it's like one of the other questions that
Yep. So a good example, like if I had been asked to explain like what F would mean, I would say the total distance traveled by the particle from t equals 0 seconds to t equals 3 seconds. So we'll practice a lot more with explain the meaning, especially as we go towards the AP test, because it is a difficult point to achieve. All right, you guys have been troopers. Are we feeling a break? All right, let's take 5 today. Thank you much. Yes, if you need to go to the bathroom, you're good. Then we talk about bananas. No. Minions.
I don't get the egg.
You don't get my acronym?
Why is it funny?
I don't know. All the boys always think it's funny. Okay.
I think it is actually.
Okay. It's usually the same ones that laugh at when I talk about inscribed versus circumscribed rectangle. The basketball team's not going to be here tomorrow. How surprising.
It said, I thought, look at the weather, it said it's supposed to like snow on Saturday.
I know, I heard that.
Kind of weird.
Woo. All right, who knows? An African country south of Mali.
South Africa?
I'm the Worldle. I'm so bad at it. Yeah.
South Africa?
Is it South Africa?
I don't know.
Wait, the globe?
No, it doesn't look like South Africa.
Oh, wait, is this the world?
Yeah, I'm really bad at
Oh,
it.
I
so bad
feel
at
like
this
I
too.
yeah, I can get that.
I can usually-
Yesterday was Israel, and then today is like this country.
See, I'm so bad at geography.
No, it's
The only one I got really well was. Did you get it?
No, I got
Is it a country I'm gonna know?
I know, it's so easy after I leave.
Oh, is it
Ghana?
Cote d'Ivoire?
I
What?
the TV.
Let's go Ghana. That's a country I know. I just don't know anything. Ooh, 97%. What did you say? You said a weird country.
Wait, what is,
Ivory Coast?
It's the Ivory Coast. It's
Oh, it's- Oh, that one.
Yeah.
yeah, no, it's like,
How do you know that, Quinn? I don't
didn't
deserve
know
that.
that one.
I don't
I
deserve
didn't
that.
know that one.
What is that?
Oh, so it's a little easier. You have to like start by like guessing a country.
How do you spell it? OBLE?
Globe LE. No. No, yes, Globe LE.
It looks like global. This one?
Yes.
See, I'm really
So
bad.
the darker red it is, the closer you are to the country.
Okay, hold on.
It's like the
Let's do. No, the other one I'm really bad at because the darker red. So if mine's just like straight yellow, I'm doing real bad.
Yeah.
Okay, cool. I'm gonna close that for now then. All right, so let's kind of end our talk today with a little talk about rate in, rate out questions. These are by far my favorite free response questions that hit multiple parts of our school year. So we're going to try to get as far as we can through. I will tell you these two questions are within like the last 5 years of the calc exam. And there are so many other examples of this type of question. They really like this question. And I think it's a question that looks hard when you first see it on the AP exam, but ends up being one of the easier ones. It looks really hard because usually it's pretty darn text heavy. So what we're going to do, we're going to read this together, kind of pick out the important pieces of information, and then we'll try the first couple of questions here. So we got a grocery store. Imagine your favorite one. I'm imagining Wegmans. You can imagine you're at the banana table. First important piece of information. Currently, 50 pounds of bananas sitting on that table. All right, we've got some customers are removing bananas from the table at this rate. Now, it's important when we're given an equation, a graph, whatever, to know whether it's a rate of change or whether it's an amount of stuff. In this case, we have a rate of change, and I'm actually going to label it rate out because this is customers taking those bananas out of our table, our situation. All right. We do have a domain restriction on this from 0 to 12. What is it? Hours. Cool. We also have some units at the end of this first paragraph. Are measuring in pounds of bananas and hours after our store has opened. All right. Those are kind of the two most important pieces of information there. Well, let's keep reading. After our store has been open for 3 hours, employees add bananas to our table display at another rate modeled by this guy. Again, these functions are a little nasty, so we're going to put them in our calculator. And Derek, I believe you're right. This is our rate in. One thing to notice, this is a little weird, and I've actually only seen it in this rate in, rate out question. Notice our domains for each of our functions or where these are applicable start at different times. That's going to be very important for our question. A lot of the times they start at the same time. But this one is one of my favorites because they added that extra little layer in. All right. Again, all of our units are the same. We've got pounds per hour for our bananas, rate of change, pounds for bananas, hours for our time. So let's look at this first question. This was part A this year. I believe this one had 4 parts. Part A, I am sure by the time we get to the AP test, literally everyone in this room can get part A right. So let's talk about it now. We want to know how many pounds are removed from the display during the first 2 hours when after the store is open. So let's start with, will I be working with F of T or D? F of T. I know I want removed, so I want to work with the rate out. Now, what calculus thing will get me from a rate of change of bananas back to an amount of bananas? An integral. So I'm going to integrate F of T. Now, when you're writing your work on the AP test, you're more than welcome to write kind of the function's nickname, if you will. So you could write F of T. You can certainly write the whole function if you want. I just don't like to because I'm lazy. What's kind of missing from my question? The bounds. Thoughts? 0 to 2. All right. Now, as I go to do this question, I liked that alpha trace thing we were doing. So what I'm going to do is immediately in this question, I'm going to go to Y1 and Y2 and put those equations in. Just for my sanity, I'm also going to label where I wrote them on my paper. So I'm going to label Y1 F of T, Y2 G of T. And I'm going to take a long time to type these in. I do notice again that I have trig in these, so I could do another verification that I am in radians, that we just did it. So I'm cool. All right, 10 plus 0.8x sine. All right, really checking to make sure I plug these in because I'm going to use this for multiple parts. Natural log, if you're looking for it, is a couple above your on button at the bottom. Again, using X since we are kind of using our calculator lingo. All right, kind of look up here when you're done typing so I know.
Is the way to plug Y2
Yeah, so that alpha trace menu actually brings up all of Y1 through Y0. So you could have a bunch of things stored in there. Usually you'll only have like 2 equations max that you'll need to be referencing. All right, we cool? All right, so I'm going to go back to the home screen. And I am going to try to integrate something. So I'm going to go math 9. The bounds we put down that you guys told me were 0 and 2. And then I'm just going to check. Yeah. Because you're in the graphing menu and you're not on the home screen. You can either rage clear or press second quit. You might clear out your function though, which you don't want to do. Sorry, Sadie, if I made you rage clear your function. I just said that. Easiest way is like second quit, so the blue button and the mode button right next to it. Yeah, that's the one really annoying thing about these calculators is if you clear something, you kind of have to go back and do it again. All right, so now that I'm back on the home screen, I'm going to put in F of T, which I have stored in Y1. So I'm going to do alpha trace and Y1, dx at the end. Hopefully we all get the same number. That was fast. All right. So we went and we put this function, our rate out in Y1. We put our rate in Y2. So you'll notice in my calculator, I have this guy in my Y1, this guy in my Y2. If you have a question that uses the same equations for multiple parts, it's nice to put them in at the beginning. Then I'm going second quit to get to the home screen. Math 9 to integrate. So I'm kind of trying to do this thing that we just typed in. Going from 0 up to 2. We'll alpha trace this guy to get Y1. And the X's, that's my letter. And I get something slightly north of 20. All right. Now, this question doesn't ask it, so they can't grade it, but I would like you to get in the habit of putting your units down anyway. What 20 what? pounds of bananas. So again, we took a rate of change and we integrated it. So it kind of removes that prime, removes that rate, and we're back to an amount of bananas. All right, I'm going to try to do just this last part B, and I think we'll save the last bit till next time because I'd like to be able to do all A through C with a kind of one thing, and it'll help to review. But part B is like, I think, just my favorite free response question that gets asked. So we are going to try to do how many pounds of bananas are on the display at t=8. There are 3 pieces of information I need for this. Can anyone name them in words? Yeah. That's fine.
One thing I noticed you should do is maybe you can divide that 20.051 by 2 and then multiply that by.
Whoa, wait, what? I'm not.
Because for question A, it's asking how many are removed for the first 2 hours.
Yeah.
So if you divide that by 2, that's how many are getting removed per hour.
Ooh,
Multiply
okay.
that by 3, and then that's how many you can subtract.
Okay, so I like your idea of the thought process, but we don't know what the function f of t is doing, whether it's linear, whether it's whatever. So we're going to have to trust our calculus to do some of that stuff. But I like the idea of using this in some form, this kind of idea of taking the ones that we remove and using it in this, because we're going to have to know how many were removed total. So how could I do, instead of like trying to finagle this number, how do you think I could get the total amount removed? We have the amount removed between the first 2 hours. What do you think I could adjust? Why are you guys doing 3? Does it, oh, I know why. Does it ever say the customers stop removing bananas? No. So what time should we really end at? 8. Wondering where your 3 was coming from. Thought I was being dumb. All right. So we'll also have to integrate g of t. Here's where that 3 is going to play in. We want to stop them adding them on at 8, but when do they start adding them on? 3. So this is one thing that's kind of interesting about this question. Usually those bottom bounds end up being the same. In this question, they're different. Now, I want to keep track of signs though. For g of t, those are being added to the display, right? So I'm going to add that on. What about the ones being removed? Negative. All right. I said there's 3 pieces of information. We got 2 down. What am I missing? The starting number. So we need to have the 50 from the beginning. So we have our initial amount minus the amount we removed plus the amount we added. All right. I think this question is cool because I think that makes a lot of sense. We want to take how many we had, take away how many we removed, put in how many we added. Now, this is going to be kind of a butt to put in the calculator. So let's see if we can all do it. And we're going to end there. And I'll let you practice it. Everyone loves practice. All right. I would highly recommend, I am team 1 step on the calculator. Some people will do these 3 numbers in 3 different steps and then kind of add or subtract them. I like just writing it in one line, and Alpha Trace helps a lot with that. So I'm going to do 50. I'm going to subtract math, 9. First integral was 0 to 8. And checking back on my paper, that was f of t that I put in y1. So my Alpha Trace, y1. Then I'm going to add on my integral. This one started at 3 up to 8. Here, kind of like Herbie was asking before, Alpha Trace, instead of choosing y1 here, I'm going to choose y2 wherever I put it. So if you didn't like y1, y2, put them in y3, y4, whatever. Just make sure you know where you put them. Again, your calculator might take a second to think about this, but you should be getting this number.
Oh wait, I can't.
If you ever need to adjust slightly, you can scroll up and press enter. That will get you what you typed in before. if you need to like insert something, so let's say I wanted to like insert a 1 before this, since it won't change anything. Second, and then this little INS will let you put stuff in. So the little INS above delete will let you insert stuff. Yeah, Daniel.
I'm just curious, so if we do like the entire math correctly, let's say we plug in like y2 plus, or like if we just like mess with the order of it, and we have the math correctly on paper, you can just like mark yellow or?
Yeah, so if I were doing this on my test, I would probably, so if your setup was right, so like everything I've written down right here was right and your number was wrong, I would probably do the silly highlighting on that. Even on the AP test, there will be, I would say this question is probably worth like 3 points-ish. You'd probably get at least 2 for the setup and only 1 for the answer. So it's really beneficial to write down your work because you're only losing a little bit if you're plugging into your calculator wrong. Paper. Yeah, because how annoying would that be to do on the computer? All right, so that was what, 23.347 pounds. Yes. So cool part about writing your units. So I know in this one, if I were grading the units, it would say indicate units of measure somewhere. If you write down the units on this and you get them wrong, if I'm not meant to grade them, I can't take off points for that. So just keep in mind, I would get into the habit of putting your units, because even if you do them wrong here, no foul play, but it'll help you get in the habit of having those units there.
You have to also have a time.
No, we don't. Not in this case. Again, that might be like explain the meaning. We could put the time there, but this one, they're just looking for the number. Actually, let me see if I can find this question. AP Calculus free response. But if you didn't know, all of the previous free response questions are posted online. Scoring guidelines. There we go. So this is kind of what a free response section looks like. P.S. If you're interested, Ms. Royce and I are setting up a mock test. Did I tell you about this already?
Yeah.
If you're interested. So here we go. We did this first part. So the 20.051, that first one we did was worth 2 points. Kind of like I was talking with Daniel, that integral is worth 1 and your answer is worth 1. And this explanation is not necessary. They kind of do their ideal. So if you had this written down, that would score the 2 points. And then the other thing we did was this guy right here. You get 2 points for the integrals, probably for the fact that they have the different bounds, and 1 for the answer. So if you had somehow typed into your calculator wrong, you would get 2 points for the setup and then 1 point for your, lose that 1 point for your answer. All of the free responses are out of 9. In general, if you're getting about 5 points out of 9 on all of the questions, you're like doing really, really well. So one thing we're going to kind of talk to ourselves about is changing our expectations as we move towards the AP test. If I haven't said it already, about a 65 on the AP test, plus or minus a few points, is a 5 on the exam. If you're getting about a 50% on the exam, you're getting a 4. So we're going to adjust our expectations as we move closer to the exam. The free response are just straight up hard. So we're going to practice a bunch with these as we review. My promise personally is if anyone gets an 100, there's like maybe 8 people who do it a year for AB. I will personally throw you a parade in downtown Leesburg. Because that's the only score they tell you. Otherwise, you just don't know. There's 108 points. They only tell you if you get 108 out of 108. No one's done it yet. In my at county. Well, while I've been teaching. Probably my fault, you know. So you have 45 multiple choice and 6 free response.
Has anybody gotten a perfect score on any AP exam?
Oh, yeah. Yeah. I don't know at county. We had one kid my first year of teaching who did the SAT perfect twice. It's like the smartest kid I've ever known. His name's Mason Hale. I think he works for Google now. So like this is what this free response question looks like. So you have 6 of these. They might not be as text heavy. It's long. It feels bad.
You do it all in like 1.
3.5 hours, yeah. So that's why I'm saying like maybe try the mock test because it helps you figure out like what that actually feels like for your brain. And we'll practice specifically with the free response. This is mostly what we'll practice as we move towards the AP test because these are the serious ones. Like the multiple choice, we've done multiple choice questions before. this is where we need practice. All right, so I want to stop here mostly because I do want to do this fish question. But notice it's very similar where we've got a rate in, rate out kind of thing. But this part C is actually a really hard part. I want to give it the time it deserves. So we'll do this one question at the beginning of next class, and then the rest of class will be yours to do whatever you want with. I will not bother you unless you ask me to explain something. So we'll take probably this one to do it right. We'll probably take 15 to 20. The rest of the time will be yours. We'll do that right at the beginning. So it'll let your brain review this stuff. I would love just to see if you are feeling good about plugging stuff into the calculator and about what we did today. 2 questions. Notes check. They're all the same though. So show me your setup. Show me your answer. Be nice. Help each other.
Well, there's questions like this actually.
But I'm not very creative. So though I'm creative in context, so I may rewrite the context of the question so it's not bananas. The idea of rate and rate. 30 hefty?
We are?
No, that would be. I have to remind myself. I've been telling people I'm 30 for a while, and that's a lie.
It's a lot.
That's a lie.
I feel like that's something.
Once you get old enough, you forget you changed age.
I don't think it like.
Yes.
One
No,
year's
so-
not that much.
Yeah, but I don't like lying to people.
Like, I don't even know my parents.
Yeah.
In my house,
My husband did it. It's close enough.
No. So I was working on senior stuff, but it will. Actually, I could probably create it.
That's great.
You guys want me to pass your quizzes back while I'm chilling here?
Yes.
Is this like the first one you did?
Just like the first one we did.
The part-
The first question is like the one we just did. Number 1, kind of that rate in, rate out. The second one is more like the first page for the PDF.
At a certain point, are you gonna expect us to do this without a calculator?
So I could if the function was way nicer. That function you actually would do.
Why did I thought it was square, but that's the thing. Like everything.
The first step is plugging these into y equals, right?
That's what I would do.
Such silly mistake.
Or since you're only doing one question, you could type in whatever you want.
Some of them, you know, I have like, it's, I guess, blank on it, like, circle one.
Sure.
I got it. I lost the one I put in, so when I didn't be able to go long thing. Like long units.
I got 25 on,
I don't remember
yes,
anything.
I did unit squared. And I honestly wasn't sure.
We're reviewing like all the
Should be
old
mine,
sections.
Yeah, so we should actually, let me show you.
I don't completely remember like units 1, 2, and 3.
Yeah, so I will probably also be posting a bunch of resources because we're a little short on time just because this year has been hard to teach in. I was looking at
So I did have one question about this quiz.
So I should be done teaching you guys right before spring break. So I'll probably send you home with some multiple choice over spring break if you want to do that as like an optional grade. And then the review will be focused on for your response because that's the harder thing.
So we have nothing after May 16th?
We will be doing stuff, just TBD on what we're doing.
Okay, and what about senior outreach stuff, like,
If you're doing outreach, bye.
Adios.
Yeah.
no more grades?
No, if you're doing outreach, you don't come to class, you don't do assignments, you're just done after May 16th. if you're here, generally what I've done in the past is do a little bit of like very easy preview into BC topics. So there's a chapter in BC called Integration Techniques that has just like more ways to integrate than we know in here. Just learn them very slowly. Yeah, who is going to be here after outreach? Just 1, 2, 3, 4, 5, 6, 7, 8 of you.